In the rugged caves of Atapuerca, northern Spain, lies a discovery that is rewriting the earliest chapters of human history in Western Europe. Unearthed from layers of rock between 1.1 and 1.4 million years ago, are fragments of a face so old, so primitive, that they may belong to a species entirely new to science. Scientists have nicknamed this specimen Pink. But who was Pink? And what can those broken bits of bone tell us about our ancient past? In 2022, in the cave known as Sima del Elefante, the pit of the elephant, part of the Atapuerca site complex in Burgos, researchers uncovered bone fragments from what turned out to be the left side of a middle face, including cheekbone, upper jaw, and nasal region, belonging to an adult individual. These bones were discovered deeper in the sedimentary layers than many other hominin finds from this site, indicating they are older than some previously known remains. Dating techniques, including stratigraphic analysis and comparison of sedimentary layers, have put their age between about 1.1 and 1.4 million years. That places Pink well before Homo antecessor, the species previously thought to be among the oldest known in Western Europe. What makes Pink fascinating and controversial are its anatomical features. The midface is more projected and massive than that of Homo antecessor, and its nasal structure is flatter, less prominent, more like Homo erectus. Because of this mixture of traits, researchers have given Pink a provisional taxonomic label, Homo affinis erectus. Affinis meaning related to, but not exactly the same as Homo erectus. However, the fossils are incomplete. There is no forehead portion, only partial jaw, cheek, and nasal bones. Sex and age cannot yet be definitively determined. There is enough to compare facial structure, but not enough to perfectly place Pink within established species without some uncertainty. Researchers note that Pink is more primitive in some ways than Homo antecessor, which had more modern facial proportions, but also shows derived, more advanced traits too. This mix suggests either a lineage that diverged early and survived in Europe, or possibly multiple waves of human ancestors entering Europe. But Pink didn't live in a desert. The landscape around Sima del Elefante at that time was much more humid and forested than today. The site's geological and botanical evidence indicate a warm, wet environment, with trees, shrubs, watercourses. Plants like hazel have been recovered in pollen records. Stone tools made from local materials, quartz and flint, were found in the same layers as Pink. These simple tools, often just flakes and cobbles, show signs of butchery on animal bones nearby. That suggests Pink or its community was capable of processing meat, perhaps scavenging or hunting small animals. One remarkable detail: some bones of prey animals show cut marks. These are clear signs of human interaction with meat processing. Life for Pink likely involved carrying raw materials, making and using tools, and defending themselves from predators. The humid environment would have meant rich vegetation, water sources, but also dangers: carnivores, disease, seasonal changes. Surviving in that setting required adaptability. Why is Pink so important to the story of human evolution in Europe? First, because it pushes back evidence of recognizable hominin presence in Western Europe with partial facial fossils. Before this, Homo antecessor was oldest in that region, about 850,000 years ago. Pink predates that. Second, Pink suggests that hominins with Homo erectus-like traits, primitive facial structures, were present in Europe earlier than we thought. This raises questions about how many migrations, population replacements, or coexistences might have occurred. Did an early group arrive, then die out? Did another group follow later? Or did several lineages overlap? Third, this discovery helps us refine the migration route out of Africa. We know that Homo erectus was present in Asia and possibly spread toward Europe. Finds like Pink show that some of these populations made it into the far reaches of Western Europe, adapting to new climates and landscapes. Finally, Pink underscores how incomplete the fossil record remains. Small changes in stratigraphy, new finds in deep layers, or improved dating can reshape our understanding. Each fossil, especially faces, is precious because facial anatomy provides strong clues about species identity. Pink gives us a face, literally, to one of our ancient relatives. Yet many questions remain. Is Homo affinis erectus a truly new species? or a variation of an already known one. The fossil material is not enough yet for a definitive conclusion. Researchers caution that more fossils are needed to confirm its status. What was Pink's lifestyle? What tools exactly were used? What diet? How social groups were structured? How did Pink and its contemporaries deal with climate change, seasonal fluctuations, predators? Evidence of cut bones suggests some use of meat, but the full dietary breadth is not known. Another question: did Pink coexist or overlap with Homo antecessor in time or region? Or did its lineage die out before later waves of hominins moved in? This has implications for understanding extinction, migration, competition, and adaptation. Finally, new technologies, 3D imaging, CT scanning, microanalysis, are helping to reconstruct faces and bones with greater precision. As more fossils are found and more sites excavated, our map of early hominin Europe will likely become more detailed and complex. Pink is a milestone, but it is not the end of the story. Pink, with its ancient bones, its imperfect yet telling face, reminds us of our deep history. A history of migrations, of survival in uncertain landscapes, of fragile bones recording stories lost for 1,000,000 years, until now. As science digs deeper, as time reveals more, we gain glimpses of those who came before us, ancestors who walked where we walk, faced dangers we can only imagine, and whose lives shaped the path to Homo sapiens. Thank you for joining us on this journey back in time. Until the next discovery, the story of our origin continues to unfold.